a bit two goals. One, to introduce Qiskit if you have never used it, and then give some tips and hints to people that are familiar with Qiskit, but maybe they joined this quantum library not so long ago. So the idea is to talk about almost these 9 years of Qiskit, and let's go to it. So first, I will explain what is Qiskit, why should you care or use Qiskit, then how can you start using Qiskit, and how to get involved. This is very important because you as a user, as a student or researcher, you can already start contributing and suggesting changes and steering the direction that the library is taking. And then I will focus on talking about the evolution of Qiskit. So almost 9 years. This was born 2017, and we just got a new release some days ago, beginning the first week of January. And I will end with what is next for the software part of the quantum endeavor. A little bit about me. So I also have a background in physics. So, but the dark matter and high energy physics is almost completely forgotten back in the bachelor. Still, I did a bachelor in Spain, bachelor thesis with CERN actually, and then my master thesis more on the theoretical quantum side in Ulm in Germany. And currently I'm doing a PhD at the Zurich as an external project. That's why I'm affiliated with the Hochschule in CERN as well. And I'm working in quantum cryptography. And then I got involved more and more with quantum computing, basically because, as Pavel said, we started a quantum computing course. It was nice because I think in Geneva I said we were the first. Then I learned that maybe we weren't. But yeah, I'm also interested in cybersecurity in general, and now we are also trying to bring some of the learned lessons from best practices with classical computers also to quantum computers. And about this, we published at the end of last year a paper about this. How can we move these reproducible builds also to quantum software or to the actual current quantum tools? Yeah, and I'm at the moment applying to become a Qiskit advocate. I will talk a little bit more about this opportunity and how you can join us for that. So, okay, what is Qiskit? First, is anyone using Qiskit here? All right, perfect. So you already know that it's an open source, it's a library, it's a software development kit, SDK, and it's targeting for quantum computing in general. It's not specialized in let's do just optimization, let's just do simulation. No, they aim to be more general. It's mainly developed and maintained by IBM. And although the first code, the first release back in 2017 was a pure Python library, nowadays they're in the process of rewriting most of the core components into Rust. And most of the simulations that we can do with other packages like Qiskit IR, they're already written in C++. And this is quite new actually from end of last year. They also have a C library and they're pushing in this direction. So the goal is that in the next years, maybe this year, end of this year and 2027, they want people to be able to install like C or Rust custom gates that you can just import into Qiskit. It's very modular. It has mainly 2 core packages. So this is Qiskit. In the past, I will mention this later, but it was called Qiskit Terra. Now it's Qiskit. And then the Qiskit IBM runtime, that this is what allows us to communicate with the IBM devices, so the QPUs. And then, yeah, there are dozens of packages around this. There are add-ons done by people, by researchers, and there are also other packages, specialized packages like Qiskit Finance, Qiskit Machine Learning, Qiskit Optimization. And I think the most popular is this Qiskit IR, which is done to do classical simulations of the quantum computing. And I want to emphasize this, that the development and features are clearly aligned with IBM hardware, even though they are trying to be as general as possible and they want their library to become like the standard to work with quantum computers, is still clearly aligned with their hardware. Nevertheless, there exist some providers for other hardware. So you can do your circuits in Qiskit and then you can run this in Amazon Cloud, or you can run this in Google if you have access. If you are digging in the source code and if you visit GitHub, they have 2 different organizations. One is Qiskit and then Qiskit Community. Let me show you this very quickly here. So this one, you see here the official documentation, Qiskit and other packages, and then the Qiskit Community. The main difference between these 2 is that The first one is the actual one supported and maintained by IBM, while the second one is actually driven by the community. So if you are working in an industry and you are really interested in optimization, you can apply and actually at the end become the main supporter or the main developer of one of these packages. And maybe in the past, if you check blog posts or tutorials, they're also referring to code in these Qiskit extensions. This is archived now, so the code there is not supported or maintained anymore. So as I said, everything from IBM officially supported in the Qiskit organization, the rest in the Qiskit community. And then there is this Qiskit ecosystem platform that if you have a cool software, if you have done an application, a custom gate or an add-on or whatever, you can apply for your core to be shown here. So this is the website, so ibm.com quantum ecosystem, and you see here all these repos. So you can sort from popularity based on the stars in GitHub, and you can filter also by the language, C++, Rust, whatever, or the topic. So for example, if you want, I don't know, you are interested in finance, well, there's only one at the moment. If you're interested in optimization, then there are these. And some of them, they are not even in the Qiskit community organization. Yes.
Is the new version backlog compatible? This is really annoying.
I will talk.
Every year I have to rewrite the code.
Yeah. I will talk extensively about that later. Yeah, don't worry. The short answer is yes. For 18 months now, there is that compromise from IBM. But this is only since 2024. So I will explain how this and why that was the case. And this is important. So before Qiskit was actually a meta package, which was fixing the versions of a set of packages. So it was installing Qiskit Terra, which was the actual implementations. What we nowadays we call Qiskit, it was Qiskit Terra. Then we had the Qiskit IBM runtime, the Qiskit, the IR, etc. And this was all fixed together in one meta package. So if you install the meta package, you know that all that works together. Otherwise, if you install the last version of Qiskit Terra, maybe it doesn't work with the last version of the IBM provider. This has changed. And that's the reason if you go to the tags of the repo, if you check the tags, there is a jump from 0.25 to 0.45. This is because the actual current repo was the older Qiskit Terra. So that's the confusing part. So here, if you go to the release notes of the last meta package release, which was the 0.44, you see the correspondence between the Qiskit meta package version and the Terra. So that's why then when they decide to restructure this code, they said, okay, let's use the highest version, which was the meta package, and Qiskit Terra becomes Qiskit. We get rid of the meta package, and now the next release after 0.25 is the 0.45. That's why there's the jump. I think you could see here. Qiskit. Can you see this as well? That's too small. I cannot make it. How is this t-shirt? Version. Let's do the other way. Yes. So this is the last version. So the 2.3.0. And if we go down, you will see that there's a big jump from 0.25 here, 25.3 to 0.45. But this you have to be careful because GitHub, they also change the automatically the release and the tags. So there is a mix sometimes between Qiskit Terra, Qiskit meta package, so you have to be careful to know what was what. All right, this I already show. And then why Qiskit? I mean, here you are using Penny other people are using the Amazon bracket, some people are using Google Circ. So I still claim that this is the most widely used SDK for quantum computing. This is the order at the moment. So Qiskit, Penny Circ from Google, and Bracket from AWS. This I basically took the stats from the PyPy. So this is the Python repository where you can download the packages. And I mean, this is public. So if you go here, you will see that Qiskit is one order of magnitude more download. So in the last month, over 600,000 If we check the next one, which is Penny Lane, so we are 146,000. But it's getting there. I mean, in the past it was mostly Qiskit and then a bit of the rest, but now they are clearly competing. And then I also claim that they have by far the largest set of documentation, both in terms of the API and then tutorials, guides, videos. So this is really nice. And I invite you, if you have checked this in the past, so in the past they had a textbook. It was called the Qiskit textbook. It was like a set of Jupyter notebooks. This was archived, it's not maintained anymore. And now they're replacing this with their own website. And they have very nice tutorials and guides that I invite you to check it out. They also have a very active community. They have a Slack community. They organize a lot of Qiskit events, hackathons, summer schools. They have a challenge every summer. So this is really nice if you are teaching, because then you can convince your students to participate. At the moment, for example, ETH Zurich, they are looking for 2 students to participate in this hackathon in April. So this was announced actually last week, I saw it. So if you know students at ETH or maybe it's also ETH, then have a look. You have here all the details, but I think the details of the hackathon and what the problem they want to solve is not public until you are there. Yes. All right, and how to use Qiskit. So unless normally, I mean, I guess most of you are Windows people or Mac people, I don't know. Any Linux people here? Good. So if you are using Linux, or actually, well, don't try to install Qiskit from the package manager, because this is still not available in the most distributions. It's also not included in most Python distributions, like Anaconda, or they have really outdated versions. So my recommendation is that you create a virtual environment. You can use the standard one from the Python library then, or you can use UV, whatever you prefer, and then you install their Qiskit and all the packages that you need, and this will work. I also recommend that you use Jupyter Lab. I mean, we have seen how this is fantastic for students because they can try and error directly there. They don't have to write a full script, run it. You can just try with a single cell. You can also do the plotting there. For teaching, you can show there the math directly. You can write LaTeX, so it's perfect. And then also, if you are teaching, you can create auto-graded exercise. And this is how we do in HiSLU, use MVGrader. So my recommendation also is that you start learning with the core packages, so Qiskit and the Qiskit IBM runtime, which is, before I mentioned that this is how you interact with the IBM machines, with the hardware, but they also provide simulators. So you can start with that, and then you move to whatever you want to specialize. If you want to focus on optimization, then try Qiskit Iron optimization, or if you are more into machine learning, then give it a try to that. Still, remember that these are not officially supported. Yes, they're supported, but not officially driven by IBM. So if you're really into this, you can actually steer the direction that these packages are taking. For example, if you really like something from Penny Lane and you would like this to be included in Qiskit, you can also work on that. Let me see if they move it. So this is in the Qiskit community organization. So this is not directly maintained by IBM. The IBM did, no, nothing like that. So they move away. Before it was happening that IBM, they open a lot of repos and then they let them die. And they are not even compatible with their own library, right? But this is not the case anymore. So if you check this, this is quite active. So this was released weeks ago. It's totally compatible with the Qiskit 2 branch. And then, I mean, the clear goal of IBM is that they want the experts in the fields to focus on the applications, and they want to focus on the hardware and the integration with the hardware. So that's why here, if you were actively collaborating, you can become and you can apply to be the maintainer of this repo. And you can see the people that are contributors. And there are still, I mean, I already saw one icon here. So this Lena, so she works here in IBM Zurich. So she's also committing to this repository. So you see that there is still work from IBM, but as well here, this is the release manager from Qiskit. So yeah, but don't think that whatever is in the Qiskit community is abandoned. No, that's not true anymore. All right, and the final recommendation is that use the 10 free minutes. So with a free account, you can use real quantum computers, 10 minutes of computation for free every single month. So just give it a try. Now with the new platform since October, I think you have to give a credit card, but still they will not charge anything if you stick to the open plan. Yeah, and also they will not trick you, because if you check the prices, it's like $90 per minute or something like that. If you are over your 10 minutes, it will not start charging you. You have to change the plan from the open plan to the paid one. So that's fine. Yeah.
That's very good because I was
Yes.
a little bit unsure.
No. So for example, for the paper we wrote, we wanted, so we did the local simulations, but then we wanted to run on the actual hardware, and we did that. And when I finished the 10 minutes, it was deleted. So the job gets sent to a queue. They check your subscription. They say, oh, you don't have any seconds left, so we cancel the job. And then you can wait and you will run the next month. All right, so here I put just some links so you check it out. This is the new quantum platform. I would say that they did a good job compared to what they had before. So now it's clearly organized. They have the documentation, they have the API reference for the official supported packages, so the ones from the Qiskit organization. So the Qiskit SDK, the IBM runtime, and then here you actually already have the C library that I mentioned before. And then you have the tutorials. So before it was a bit confusing because you had these tutorials, guides. So now they clearly separate the API reference. If you know what you're doing, you just want to see how you should call a function or etc. And then you have the tutorials if you want to get started with Qiskit or if you want to work in one specific topic. For example, if you want to work on Qiskit error mitigation, you have these 3 tutorials at the moment. And this, I have seen since they started this new platform, they keep adding new tutorials almost every month. All right. So how can you get involved? How are we doing on time? Good, right? It's still 15. How long? Perfect. So how can you get involved with Qiskit as a researcher, as a user? So first, report issues. Qiskit, I mean, they have plenty of issues. If you have used Qiskit or any other quantum library, you will see that you will find after 10 minutes, you already find one issue. So report them. Try early on new features and report the issues you will see. This I will show some examples. So when they added the C library, they also added some C++, so you can use. And they forgot to include some headers. So I just report that and it was merged directly. So do that, don't be lazy. It takes 5 minutes to open an issue. Then fix the documentation typos or even mistakes. So I will show one example later where we were preparing one exercise for the teaching course and I found a mistake in the Grover example in their own website. You can also create a patch for their official documentation. And normally it takes a few days and it gets merged. Join the Slack community, although I would say that there's a lot of noise, but maybe it's nice if you just put the notifications for the events. The other channels, there are a bit of too many users asking for sometimes questions, but I think now they are changing this as well, and they have some channels that are read-only. So at least you get more signal to noise ratio. And then you can apply to become an advocate. So here they have different tiers. The idea is that if you get involved, in the past it was just doing a form. I tried that, but now you have to do at least some official courses from there. I have done in the past the certification, but it was back from the 0.3 or 4 version. So now they have a new certification and the old one is just, they ignore that. So if you become an advocate, then you get access to extra material. They can even fund events. So if you decide to organize one event in a Hochschule or a university or then whatever, IBM will provide people money and time. So they will send one expert from IBM, and this you can check. They have done events all around Europe, in Spain, in Bilbao. I think the last one was in Slovenia. Yeah, I don't know. They're doing a lot of work, and I think the problem they are lacking people. So yeah. All right. So these are the examples of that I mentioned. So I just took the most recent ones. So this is from 2025, so September. Let me show you here bigger. So this was Qiskit 2.2.0, so quite recent. It was reported September 19. And this, I mean, I have a set of tests that I run myself whenever there is a new version of Qiskit, just so they don't break the exercises in our teaching course. So I just rerun that and I realized, oh, now this is not working. What's going on? And there was a regression. And so actually you can fix certain seeds. So when you generate random circuits, they are always the same. So you can have a random circuit, but then you can reproduce that in a deterministic way. And this was broken. And you see that I reported this September 19. In this case, it was just report the issue. I didn't dig down in the Rust code. And then one of the maintainers, 2 days later, it just fixed it. So you see that reporting the issue is actually nice, and they solved this. And 2 days later, there was the 2.2.1 fixed release and problem solved. This was the one that I mentioned before. So I wanted to give a try to this C low-level library, and they also have this C++ repo. And yeah, I tried to do the most simple program you can imagine. It was just to define some gates and try to compile that, and it was failing. And the problem is that they don't have at the moment a proper CI for testing this C++ library, and it was just a missing header. So this, instead of just reporting the issue, I created a pull request. You see that they changed, and that's why my contributions are a running error, because it's just one line that include algorithm that was the header that was missing and fix the problem for me. So you can take an active role actually in Qiskit. And then this was the example I told you about the documentation. So we were creating actually this notebook about Grover. There was a recap. As you can see here, we explain the theory. We always mix the theory with examples, coding with Qiskit, and then basically here we do a quantum oracle, and we implement a quantum search in a 3-bit search space. So really small, but it's something you can do with the current hardware. And the problem is that this was not working as expected if I follow exactly the documentation. And it was just a trivial mistake, so that I propose here. So I explained the issue. I found a mistake, I fixed it, and it got merged. So this was June 13. Okay, I guess this took a bit longer, June 20th, but still, 1 week. So you see that it works to report issues and to try to fix them. All right, so let me now back to your question about how can you write code that doesn't break the next time you open your script. So let me put the perspective of these 9 years. So everything started in 2017, then we had these many versions. 7 years, they had an unstable API. There were no guarantees, and this was clearly specified in the repos. So every time there is a new release, you know that your code might be broken because they are changing, because they are removing, they are not following a strict deprecation policy. So you write a code, you open the next month, nothing works. This was the rule. And this was the rule till February 2024. This is when the first stable release of Qiskit happened. So Qiskit 1.0.0, February 2024. From there on, they follow the semantic versioning. So they compromise that if it's only a minor increase, so if it's 1.1, all your code should still work. They also provide backwards. It is true. I'm talking about Qiskit, not Qiskit machine learning.
Yeah, it's important. It is not inside community package.
The problem actually, what broke with Qiskit machine learning is that they were using, I will talk about that as well, but they were using deprecated methods from Qiskit. So they had this almost 2 years and a half, and they didn't migrate to the primitives v2, for example. And that got broken in Qiskit in March 2025, because then they are no longer guaranteeing backwards compatibility. They can remove, they can deprecate new things. And with Qiskit 2.0, they remove all the V1 primitives and the providers, the V1 providers and all that. So that's probably what broke. And actually, there are still some packages that they are not fully compatible with the Qiskit 2.0. The good thing is that they are also, so now after the Qiskit 2.0, they guarantee 18 months of support. So even if we have Qiskit 3.0 this year, which I don't think will happen, they will keep supporting the last release of the Qiskit 2.0 for a few months more. So in the case, for example, in March 2025, we have this Qiskit 2.0. We were in the middle of teaching the course. We kept using Qiskit 1.4 point something because it was supported in September 2025. And then the next iteration of the course, then we started from scratch from 2.0. And this I will talk about because it was not very painful to migrate from Qiskit 1 to 2. It was very painful to migrate from 0.45 to the 1.0. So here some are the key achievements, or let's say the major changes from my point of view. So from 2017 until 2018, if you check the code, it looks more like a personal amateur project. There were no release notes, no documentation. This changed from 2018. They started to create proper docs. They have the Sphinx documentation. They write the release notes with all the changes, the contributors. They created a contributing policy as well. In 2019, it was the first package that was not pure Python. So Qiskit was already written in C++, because with Python you could not simulate in a short time. 2020 looks, yeah, now it's 6 years ago, but I would expect that this was at the beginning, but no, the quantum info sub-package that is so useful for teaching, it only appeared in 2020. And then in 2022 is where they started to migrate to rewrite core things from Qiskit to Rust. And here's, they started first with some steps on the transpilation, and now they are even implementing the core, so the gates. Everything, they want to move away, they want to keep the Python interface for the user to code, but everything that affects performance, they want to write it in Rust. In 2023, Qiskit was decoupled from the IBM hardware because at the beginning, there was no distinction between the Qiskit and the IBM runtime, so how you interact with the machines. So in this release, they took away everything that is IBM specific away from Qiskit. So now if you want to talk with a IBM CPU, you have to install an additional package. And then before just the 1.0, it was a total restructure of the repo. So here's what I mentioned before, that there was this Qiskit Terra, the Qiskit meta package, this they changed completely. They moved code around, and this is what was painful to migrate the code, because now you have to change imports. You have to change names of the gates. Basically, it's like you have to start from scratch. It takes you literally less time to write the code from scratch than trying to migrate your old code. And yeah, and I think now in the last 2 years, the development of Qiskit has increased quite a lot. So I mentioned here a few things, like for example, the quantum circuit internal data now is written in Rust. And this is relevant, I will mention this later, because before you could access, you could iterate over this data and modify it in Python. Now, if you try to do that, nothing happens because you are just modifying a copy that does not affect the internal buffer. Now we have primitives v2, we have the native OpenQuasm3 parser in Rust, and now they are including as well the C API for translation. So this is super recent from the last few months. All right, some numbers about these 9 years. I was surprised. I was expecting more contributors, but only 627 and 60 new contributors since 1 year ago, exactly 1 year ago today, and almost 10,000 merge pull requests in GitHub. And I think this is one problem. So currently there are 847 open issues. Most of them are irrelevant, but someone has to go through them and say, no, this is not relevant. This code does not exist anymore, or this is not an issue anymore. And 245 open pull requests. And this I want to mention that some pull requests are years older, so they are not relevant anymore as well. So you see that if you report an issue and it clearly affects or impacts what IBM is trying to do, it will get merged quickly, it will get reviewed, that's fine. If you are trying to do something that, because you are interested on that, probably it will take longer, or it will never get merged, at least on the official Qiskit packages. So that's why it works better talk with some of the developers, yeah, Slack, or if you meet them, and then ask, look, I'm thinking about this. Does it make sense? Does it align with the IBM roadmap? Otherwise, yeah, I would not say that. This works a little bit, well, in a different scale, but like Android, right? You cannot do a pull request to Android if it's not aligned with what Google wants to do, even though it's open source. All right. So now I come to the technical part. So this is probably what you suffer, the migration from the 0 point to the first stable release. So to start with, you could not update Qiskit cleanly. So if you're using pip, you cannot do this, because pip cannot handle this kind of update where everything is changed from meta package to package. So you have to start fresh, you have to create a new environment. Then also because of the restructure, you have to import the things that you were using in a different manner. So before there was this Qiskit.ir to access the code that was part of this Qiskit.ir package. Now it's in a completely different namespace. So you have to change that. What was in Qiskit extensions now becomes the Qiskit circuit library. So if you were importing, probably most of your scripts were importing gates, now you have to change them as well. And not only that, because now the gates are also changed. So before we had this C node, we had Toffoli, and now that's gone, and we have CX, CCX, yeah, the primitives. So if you were getting the results from your sampler, you don't know how to get the counts anymore. So you have to read again the API because this changed completely. There was a tool available, it's Flake 8 Qiskit migration, but honestly, I tried once and it was very buggy and unreliable. So as I said, it was faster to just, you know what you want to do, read the new API right from scratch than trying to migrate the code. And this is a problem for the people that likes to use AI, because the language models, they hallucinate with old code. So if you try to use this, ChatGPT or Claude or whatever, they will still give you code that is back from the 0 point times of Qiskit. And I think that's one of the reasons that now IBM, they have their own package to do kind of AI with Qiskit. So it will autocomplete, for example, if you use the Visual Code or if you use the Jupyter Lab. So just be careful if you read tutorials, even if you check the Qiskit official textbook, because you will see code that will not run today. So take this into account. And then we had the second migration last year. Honestly, this, I think I had to change 2 lines of code in the whole course. So this was really straightforward, especially if you were not using features that were deprecated. So because of the new policy, in Qiskit 1.0, instead of changing and breaking things, they would issue a deprecation warning. If you keep up to date with that, and you were migrating slowly to the new code, the migration from 2.4 to 2.0, it was straightforward. I think the most confusing part for me was migrating the classical conditions. So you can have circuits, dynamic circuits, that they change in runtime depending on, for example, measurements. You can in the middle of a circuit a classical measurement, and depending on those bits, you can have a different set of gates acting on the circuit. This changed completely from 1.0 to 2. So now they work with kind of with context. So this was at the beginning. Now I got used to, but at the beginning it was very confusing. Also important for some students with old laptops. So they drop support for the 32 bits. So both Windows and Linux. So now you need a 64-bit platform to run Qiskit. I think this was due to Rust. Also for developers writing add-ons or extensions, or in our case, writing this paper, many things broke because they were rewriting things in Rust. So we were doing things that we are not supposed to, like, for example, accessing some of the parameters of the gate. So this was not part of the stable API. Of course, they don't have to guarantee that will not break, and they did. And then things like, for example, comparing parameters, they change because in transpilation, some steps are in Python, some steps are in Rust. So you have to keep in mind, for example, the numerical precision. You cannot assume that the precision will be kept into the Python level across all the transpilation. Or also, as I said before, if you try to modify an instruction of the secret directly accessing the internal data, you will modify a copy that is given to Python. So now you have to use the methods to actually modify the Rust buffer. Yeah, there is no magic tool to migrate code, but as I said, better not to have one. And this, as I said to you, so by IBM now is committed since the 2.0 for 18-month support cycles. So we have plenty of time. We can start our course, keep using the same version, and then migrate in the next iteration. We don't have to keep worrying that, oh no, there is a new release, now my students, everything will break down. All right, so what is next for Qiskit? How do you want that?
That's okay. I mean, I give you 4 more minutes.
Cool, perfect. So Qiskit will continue working on the performance because otherwise the software is not good enough for the next gen of hardware. So if we try to transpile circuits for the next gen, it would take forever if we use the pure Python. So that's why they keep migrating to Rust, and that's why they are pushing the C library, and this will continue in the next releases. Now in Qt 2.0, this is quite new. They introduced these boxes and stretches. So this is a way to organize. If you haven't tried this, maybe give it a try. There is already a tutorial. And the idea is that this will become quite relevant for interacting with the actual hardware with the new dynamic circuits. This is something I want to work more. I'm still not that familiar, but this is something we will include in the next iteration of our course. Then there is an open roadmap you can check in the wiki of the Qiskit repo, and this I took from there. So the Qiskit 2.4 and 2.5, so the immediate next 2 releases will continue to expand the C API. And the goal, as I said at the beginning, is that they want people to be able to import C or Rust extensions that provide custom gates. So this is the goal. At least before the Qiskit 3.0, they want to achieve this. And then Qiskit 3.0, they will work towards fault tolerant and error correction. So at the moment, Qiskit 2.0, you have error mitigation, but there is nothing about error correction. So this is the direction that is taken. And you have there the link if you want to check it later. They keep updating this regularly. So that's all. If you have any questions, otherwise I have some open questions for you.